Okay, let us start with the week number 3 is related to the application size. Okay, what are the key points or what are the information you need to include in your research proposal or the research question? Okay, as you know that you prepare the research. So the research, you need to have an objective of your study. What is the objective for this particular research? So in this course, we'll concentrate on the, let's say, the statistical knowledge. You're going to propose something is new. Okay, the objective, what is the objective? You propose the new statistical knowledge. Okay, so once you propose it out, you should have some problem with this particular topic you are going to study. Then after that, you need to provide the real application to demonstrate the applicability of your proposed distribution or proposed techniques. Okay, so the application itself is most of the time, if you publish in the research journals, they will request you to provide an applications. Okay, so today we will concentrate on the last parts on the application side. Okay, what are the information you can be provided in the application side? So not necessarily is a fixed technique, but you need to provide more information so that to justify your suggested methodology is can be applicable. Okay, so you need to support with the certain of the statistical technique to support your results. For example, you carry out the hypothesis testing. Okay, you present your technique in the graphical way or in the numerical numbers. Okay, then you carry out some comparisons with your new techniques with the existing techniques or the new models with the existing models. So these are the what compulsory or the essential work. Okay, because in people will want to know that whether your proposed technique is very useful or no. Why they still want to accept your new techniques? Okay, so these are the things is where you need to consider. Okay, so in the week number the first time I met you in the week number 5, we have discussed the literature review. Okay, so whatever you have done or you are going to start a new research, you need to know what is your objective of this particular study. Okay, so if you have an objective, then you also need to go through the literature review, whether anybody have done the research on this particular topic or not, or what are the previous study people have been done. Okay, so all these things you can find from the literature review. Okay, literature review will be you can get the information or the idea. How are you going to start the new research? Okay, so after you have a literature review, you have completed your literature review, you need to provide your methods. Your methodology section will come in. So methodology is your selling point of your whole research, because you may use the new techniques, or you may propose the techniques, or you want to compare the different techniques. So your methodology parts will be described about what are you going to do of your research. Okay. After that, you describe about your methodology. Then we go to the following section will be the application. And then after the application, you will end with the conclusion to conclude your whole study. Okay. So today, the first one I will introduce for you will be, because our course is related to the statistic, so therefore I will take a few most of them, their methodology will be the statistic methodology, and then of course the application will be describe about the methodology you have proposed or you are going to comparisons. Okay, so against the first one will be the distribution. I think for the first time I introduced during the week number 5, I have introduced for you a few research paper on the distribution. In the last week, I also introduced for you some papers on the distribution. Now, this week, I also take some papers on the distribution theory. Okay, so about the distribution will be in the statistic are very important, because if the distribution will quite flexible enough, then you can model your data. Okay, so in this paper, on the generalized T distribution, where they published in the year 2008, so this paper was related to the T distribution. I believe that most of you will know what is the T distribution, or I think all students will know the T distribution. And then from the T distribution, they generalize the T distribution. And then in this paper also, they have instead of generalize the T distribution, they have a skewed generalized T distribution. Okay, so the objective of this paper is try to propose something about the generalized, or I call as a skewed generalized T distribution, and then we compare with those of the existing generalized T distribution. Okay, so when you come out the new distribution, when you have a new distribution, of course you need to deal with when you come out with the new distribution of the here, then of course you need to study about the properties of the distribution itself. This one is what I have mentioned it to you. Okay, during the methodology section, you come out the new PDF function, the probability density function. Then from the probability density function, you need to know the properties of this PDF. For example, you want to know the first moment, the second moment, third moment, and the fourth moment. All these things were related to the mean, variance, kurtosis, and the skewness as well. So these 4 moments will be quite important. Then how are you going to estimate the parameters? Okay, how are you going to estimate a parameter for the distribution you created? So you can use the Bayesian techniques, you can use the maximum likelihood techniques. Okay, and then of course, once you get the PDF, sometimes may not be enough. So you also need to get the CDF, the cumulative density function. Okay, because all these things are the properties of the one particular distribution. Okay, so in this paper is basically they want to compare that the skewed generosity can be better model than the generosity in their application side. They of course they want to show that this thing. The second thing is during the application, they want to show that their technique is better than the existing techniques, or their distribution were more flexible to fit with the data than the existing distribution. So how they want to compare it? One of them, if you study before, is a log likelihood. Okay, when you fitting the distribution to that particular data, then you are checking their log likelihood values. Okay, so the log likelihood is one of the criteria for compare how good is the models or how good is the distribution. It depends on your study. Okay, of course, after the log likelihood, maybe some of you heard about what they call as the AIC, Archive Information Criteria, or the BIC. All these measurement are the to judge that which model will be perform better. Okay, so besides in their application, besides they can justify the skewed generosity will perform better. Besides the comparing the log likelihood values, they also carry out the test. It's called the likelihood ratio test. Okay, the likelihood ratio test will be H0, you follow this distribution. H1 is you are not follow this particular distribution. Then they carry out the likelihood ratio test to test whether the result is significant or not significant. Okay, so after that, besides the likelihood ratio test, they also provide the goodness of fit of the model. So means that they show the QQ plot or the PP plots to show that how good is your distribution fit with the data. Okay, so when we go through I will go through the first here. This paper is published in the year 2008. Okay, so about this paper, about this one is a PDF function of the generalized T. is given by the following one. Here are the parameters involved in the distribution. Okay. So this one is what they call as a skewed symmetric distribution is given by the following function. Okay, but we are not going to go through their theory, their techniques one by one. Okay, of course, in the whole paper they have come out with the CDF function, and then they have the CDF function. They have beside the CDF function. Okay, they only go through is provide you the CDF function, but of course from the CDF all these things you can know the properties itself. Okay, so in the application side, okay, they want to show that the skewed generality given in the equation 2 can be the better model than the one based on the generality distribution given by the equation 1. So you want to show something distribution will be perform better. Then of course you need to provide the empirical examples. So in the empirical example, your example must be able to demonstrate they have your distribution will be provide it better fit than the existing distribution. Okay, so this is one of the example is given by the author. They have take out this example. Okay, then after that they compare, they fitting the models. They have a model fit or the parameters estimates, and then they provide the negative L. Okay, so these are the criteria to for them to show that their model will be fit better than the others models. So they will have a log likelihood function, okay, and then another log likelihood. So when we are talking about the log likelihood, we want the value is as large as possible. Okay, but they provide here is a negative log likelihood function. Okay, they put is just a negative value itself. Okay, so we want the value is as large as possible. So this one is one of the criteria for you to checking whether your model is good or not. I believe that many students also go through the modeling. Okay, in your research, maybe most of you go through the modeling. So how good your model? One of the criteria you can consider is a log likelihood. Okay, log likelihood values, and then your model, if your model is the best, then you'll provide the smallest log likelihood. But the log likelihood may not be enough for you to justify that the model is good. So you can be extend with the AIC, BIC, okay, where the AIC they are adjusted with the number of parameters in the model. Of course, if your model consists of many parameters, most of the time they will perform better. So if you look at the log likelihood may not be enough. So therefore, you need to proceed with the AIC. That one I will show you in the later papers. But one of the criteria you want to justify that your method is can be applied and then fit very well, you need to provide some evidence. Okay, some evidence to justify that your thing is working. So in these papers, they will use the log likelihood to test, to compare it out. Okay, so the first model and the second model here. So they will expect the larger of the log likelihood will be the better. So this one, because it's a negative log likelihood, so the log likelihood should be negative 51.8. This one is a negative 55.4. So therefore, this one will be larger. Okay. So besides the log likelihood, they still not enough to justify that their work their distribution is performed better. So therefore, the author will carry out the test. So they will have it the log likelihood ratio test. I believe that you, those of you study the statistical inference, I think that log likelihood ratio test is inside. Okay. So this one log likelihood is not the proposed by the author, but is they just use to support their result is perform better or the distribution they provide, they consider. Okay, so the log likelihood ratio they were given here, they don't provide any of the log likelihood ratio, but they tell you that they are doing for the log likelihood ratio, then they kept the result of the log likelihood ratio. Okay, then after that, they also provide the probability plot. So the probability plot also will show you that how good is your model, your expected and observed, okay, as compared to the here. On the top one is a skewed student T, at the bottom is generalized T distribution. So if the point will fall on the line, majority of them is on the line, then should be they are close to that particular distribution. Okay, so these are the information given by this particular paper, where they justify that how good is their model on the generalized T distribution. Okay. So when you apply support with the application, you need to have some measurement or the performance measure to justify that the suggested methodology or suggested model will be performed better. Okay, so in this paper, they will carry out the test as well as the log likelihood, and then they do the plotting of the probability plots. Okay, so they do not have any fixed methods to do all these things. Okay, it depends on if you have any tools or any techniques to justify your how good is your suggested methodology. So you can support with the many of the different techniques. Okay, like in this example, if you just compare with the distribution wise, then of course we will want to check it out. How good is the log likelihood, the first thing. Then how good is the model fit. Then if maybe I can be plot the real data, I use the real data, this one is a real data, and then I can plot with the fitted distribution. How is it the fitted distribution look like? Okay, or the fitted equation look like? So they also can be provide the fitted equation. Okay, but in this paper they do not provide. Not necessarily you need to do so, but you can have another option to provide the fitted equation. Okay, so this one will be the first one is about the generalized T distribution. Okay, then another one will be the second paper. This paper also relate to the distribution as well. Okay, so when you are talking about the distribution, when you are mentioned about the statistic, we are always take care about what is the distribution. Okay, so the second one is proposed the generalized T Bourbon-Chandra's family of the distribution. So this is a distribution where is also widely used in the certain uh, financial time series models. Okay, so this paper is published in the year 2013. So in this paper here, in this one, they will be, because they're doing the different way, even though they provide the distribution, this one also compare the distribution, but in this paper, they will provide the data with the distribution BS and the GT BS. Okay, so they fit the data with these two particular distribution. And then because of the application here, they provide the summary statistic of the data to let them to know that what is the mean, what is the variance, and the standard deviation. Okay, so this whereas the first paper, they do not provide any summary statistic. They just show you how good the fitted parameters, the fitted here, what is the fitted values for their parameter, that's all. And then they carry out the likelihood ratio to test it out. Whereas in the second paper, they will provide you the summary statistic of the data. Because from the summary statistic, you also can be checked what is the mean, what is the variance for the data, as well as a theoretical, if they follow this BS distribution, what is the theoretical mean? If they follow the GTBS, what is the theoretical mean, theoretical variance, and so on. So they can be compared how good is their data fit with the existing distribution. Okay. So besides they provide the summary statistic, you also can be, of course, you want to know that how good is the model, then we will compare the log likelihood values is similar to the above one. Also, they compare the log likelihood. After that, instead of carrying out the likelihood ratio test itself or the probability plot. In this study, they show the distribution of the data using the histogram. So they know that how is it look like the BS distribution and the GTBS distribution. They use a histogram to present their answer. Then of course, they will carry out the likelihood ratio. So if you compare the first paper and the second paper, you can check it out. They do not necessarily must be have a systematic way to provide the answer, but at least you are the author for this particular research. You want to demonstrate your technique you propose. Therefore, you need to provide as many information as can to justify how good is your suggested methodology or suggested model. Okay, so they provide the different information. Okay, so if you refer to this one is another paper is published in the year 2013. So in this particular paper, they also is a generalized T of the BS family. Okay, so in this distribution, in this particular research work, they have mentioned to you what are the objective of them to come out with generalize the BS distribution. They will have they use a generalized T distribution alternatively to the normal distribution. So this one is what they have proposed in this paper. Okay, so let us go through to the application side. Of course, here is an introduction of the distribution, and then they mention about the property of this particular distribution. Okay, they show you how to do the transformation from this particular distribution. They do the transformation. Okay, so besides the PDF function, they also show you the CDF function. Okay, so if they show you the CDF function, of course you can plot the probability plot to check how good is your theoretical distribution and empirical distribution. Okay, and then besides the CDF function, they also provide you the hazard function. So hazard function sometimes will describe the distribution for the data set. Hazard function will be very useful. Okay, so their hazard function is equal to the PDF divided by the 1 minus CDF here. You get the hazard function. Okay. So this paper, they demonstrate for you, they have a different type of the shape of the hazard function. So you can have a different side of the shape of the hazard function. Okay. Let me go through it, the empirical example here. Okay. Yeah, so you can see here, in this example here, they also show you the moment, means that is a expector of the x power 1, power 2, power 3, and so on. So this one is a first moment, second moment, and so on. So this one will lead you to the mean of that mean. The first moment is a mean, and the expector of x squared is a help you to get, if you want to get the variance, so it's equal to expector of x squared minus a mean square, you will get your variance, and so on. Okay. So they provide for you all the expectation. Okay. Yeah, the first one, the first 4 moments are given as here. Okay. So they have derived out all these things. So during when they go for the empirical, this one is the maximum likelihood estimation. They have provide you the log likelihood function. The log likelihood function is given by the following one. Okay. So let us go through their application here. So in this example here, when they want to demonstrate their techniques, okay, of course they need to use the maximum likelihood technique to estimate a parameter. Otherwise, why they want to show you all these things? Why they want to show you the estimation technique is using the maximum likelihood? Of course, they need to use the maximum likelihood to maximize the log likelihood function. Okay, so the following one here is actually help you to get your Hessian metric, and then you get your variance covariance of your parameters. Okay, the variance covariance of the estimated parameters. Okay, so in the application here, they have shown you that 2 examples inside here. Okay, so the first one in the example here, they have provide you the summary statistic. So this is a data summary statistic. So just now you have derived out, this one is a data summary statistic here, but all this here, the mean, the standard deviation, the skewness, and the kurtosis. If you are willing to use the GTBS, this one also is another useful measurement to check whether your distribution, your mean, standard deviation, skewness, and kurtosis is close to the empirical result or close to the theoretical result. Because just now you have derived out the formula. Okay, in this theory here, they have derived out the first four moments. Okay, so based on the estimated beta and the P and the Q, they can calculate the mean. So you can be using the theoretical formula to check your mean, and then from the data set, what is your mean? Is it they're close enough, or they are very far away, or they are here? So all these things is important for you to do the comparison during you provide the empirical application. Okay. So over here, they also provide you the how good is your model of the GTBS as compared to the BS. So here are all the parameter estimates calculated, use the maximum likelihood, and then the bracket here is referred to their standard error. So the standard error, they're using the Hessian matrix, just now the above one, then they calculate the standard error. Okay, then they provide the standard error here to check whether this parameter is a significant or not significant. So for example, if the P and Q is the parameter for the GTBS, if the P and Q, or for example, if let's say Q is not significant, so it's no point you go for the GTBS because one of your parameter is not significant. Okay, so these are the things you need to take note when you apply the example, and then you need to look at your result carefully. Okay, don't just when you produce, you run your programs or you use a software to run out the result, then you just accept it. You need to do the analysis whether you obtain the result is logic or no. Okay, then after that, from the estimated parameter here, they calculate the log likelihood values. So this log likelihood value will show you that -160 will be larger than the -169. So therefore, the GTBS will have a better fit to the data than the BS here. But if you just depends on this thing, may not be enough. Okay, so people will expect you to have others criteria to justify it out. Okay, so in this paper, they also carry out the test of the likelihood ratio test. Okay, so besides that one, they also show you the graphical through the histogram to show you that how good is your data as you fit to the GTBS and the BS here. So this one is the histogram here. It show you the empirical data, and then this one is the line. Okay, they calculated from the PDF density because in this paper they have provided the PDF function. Then all the parameter estimate you have obtained it. Then therefore you just put in your parameter estimate. Then you can draw the density, the PDF function. So clearly you can observe that the BS here is a higher, where the GTBS will be lower. Okay, so this one is a further justified that your model will be better, but based on the graphical here may not be have a very strong evidence to show that your GTBS will be performed better. Okay, so therefore the graphical here is let the people can illustrate your works only. But you want to justify how good is it, you need to base on the numerical value. For example, the log likelihood values. One of them is here. Okay, so beside this thing, this paper also carry out the likelihood ratio test. So the likelihood ratio test statistic will given by the following one. Okay, also is not proposed by this author. This author does make use of the existing technique to support their proposed distribution, or they call proposed the model. So from here, once they test the following hypothesis, they now hypothesis will say that the data is come from the BS versus the data is come from the GTBS. Okay, so from the calculation of the log likelihood of the BS versus the log likelihood of GTBS, they found that the result will be go to reject the null hypothesis. So reject a hypothesis, it means that the data set will be fit well using the GTBS. Okay, so this one is what they have of the comparison between the BS and the GTBS. Of course, some of the reviewer will be claimed that why you still need to compare with the GTBS. Maybe you have other distribution where they are more flexible or they can fit well with this particular distribution. Then they will comment on your, they will give you the comment why you don't compare with those of the distribution where it's fit well with the data. Okay. So this one is in the application, you need to justify your work. Okay. Another example is given by the author will be here. It's a nickel concentration data set. Okay. So this is a data set they have. They provide the summary statistic of here. So the idea of the provide the summary statistic of here, of course, they can be used their estimated parameter here to calculate the mean, whether they are the empirical mean based on the estimated parameter here. They calculate the mean 21.34 and then compare with the theoretical mean. How far is it? I do not read through the paper, this paper here. They can be do this thing is just compare whether their mean is close or no. They also can compare with the standard deviation. They also can compare with skewness and the kurtosis as well. Okay, they just not only just provide the summary statistic only. Okay, this one is my comment of this paper where they can be do the comparison. Okay, so in this paper also they produce you the histogram. But if you you can observe that the GTBS will be fit quite well. Okay, it's a positive skew distribution where they consist of the 4 parameters distribution here. Okay, the distribution with the 4 parameter. Of course, there are many distribution with the 4 parameters. For example, the GB2 distribution also is a 4 parameters. Okay, so they still have other distribution. But in this paper, they justified the GTBS. Of course, they have their selling point of why they need to propose this thing. Okay. So this one is an empirical example under the second paper. Okay. So if you observe it out, the first paper here and the second paper here, the test they use will be quite similar, and then the way of the presenting their result in the application side, they may be different. Okay. For the first example, they use the probability plot because they have a CDF. So they can be calculate the probability of the CDF and then you compare with the empirical CDF. How good is it? But the second author here, they do not do so. Then they just provide the histogram. But if they want to do so, also they are possible. Okay, if they provide the CDF or they provide the quantile, then they can use that one to justify their techniques. Okay. So on top of them, they also provide a summary statistic to show that what is their mean and variance for the data set. But I'm not sure whether they will make use of the summary statistic there or not. Okay, so in this one, they just say that they provide the summary statistic, but they do not check whether this one mean, standard deviation, skewness, and kurtosis will be matched with the theoretical when you substitute with alpha hat, beta hat, p and the q p hat and the q hat. You substitute inside here. You substitute inside here. Then whether you can get your theoretical mean and theoretical the first ball moment. Okay. So this one I'm not sure about the beta here. Maybe the beta have a special meaning of here. Okay. So this one is what you have in your second paper. Okay. So these 2 paper will be the statistic paper. Okay. And then for the third paper, instead of the proposing the distribution, the third paper we will propose the what they call as a hypothesis test. Okay. So they want to test for the in the count data for those students who are working on the count data it means that your data only can count the number of the data. One of the problem with the count data, or they want to fitting the data to the model, is basically they need to check whether the mean is greater than the variance or not. So they need to check whether the over dispersion is happen or no. Or they can just get the mean and variance. Then they check is whether it's over dispersed or under dispersed or equal dispersed. So these are the things, if you're those students who working on the count data, you will more understand about the over dispersed here. Okay, but in this paper here, they will propose an extension of an over dispersed test. Actually, they have already the test, the hypothesis test, but they try to do the extension of the following hypothesis test. So this one is you need to support with your theory, okay? But if you cannot derive out the theory, but of course you can carry out the simulation study to justify that your proposed or your extension of the test will be quite useful. Okay. So in the third paper here, the first one is develop the over dispersed test here. And then in this example here, in this one here, the author will provide just 4 different examples to justify their work. Okay, how many examples in your research journals, it depends. But based on my experience, okay, certain if you're going for the certain publication, some of the author maybe request you to provide more example. Okay, because sometimes you provide one example, they cannot know whether your data or your proposed methodology will be useful. So therefore, they request you to provide more examples. Okay, my experience, as I mentioned, I have an experience is we provide only one data, but the reviewer will ask us to provide more examples. So therefore, you need to include the more example to justify how good is your models. Okay. So this is the paper in the third paper here. Okay. So this paper will publish in the computational statistics and data analysis. Okay. So of course they will want to test whether the over dispersion. Okay. So what they propose is they have a hypothesis test. In fact, the test was given by the following one. In fact, this one is the default one. Then after that, they try to improve it. Then they have an extension of their test. Okay. So I'm not sure that the proposed test will be given by the following one. Okay. So once they have a proposal of the test, of course they want to know that how good is their proposed test. Okay. And then they propose a new extension of the test. They also need to know that what is a critical value for you to have a critical value to reject or to not reject the null hypothesis. Okay, so proposing the test is also not the easy task. Okay, you need to provide what is the distribution for this particular test statistic. Okay, so in the here, of course, the methodology side, they will tell you, they do the simulation to simulate that what is the distribution, what is the mean, and so on for that particular test statistic. Okay, but we are not interested on this thing. In this paper here, because their idea is want to propose the test, so therefore they use a 4 different set of the data. Okay, the first data they have used the illegal gun owner data is from this particular paper, and then they justify that what is their techniques using the following hypothesis, what is their techniques here. Okay, the second paper, the second example, they also took the example from the Matthew and the Appleton in the year 1993, the data set from here, and then they want to justify their techniques. Okay, so in the first example here, they just once they get the data set from the certain journals, and then they carry out their hypothesis test. So the test itself, they will provide you the p-value. Okay, then they compare with the existing technique whether they have the same conclusion or not. Okay, then the second example also they do so to compare their techniques. Similarly, for the third one, Okay, the third one, the third example will be given by here. Okay, the third example, they also use the different data. The data is getting from the child and the Huygens in the year 2005, and then they compare their hypothesis test with the other tests. Okay, so they also show that the two tests is lead to the similar conclusion. So in this example, you can observe that when they explain their example, they do not explain very much on the data, because their selling point of the paper number 3 here is actually propose the test. So the test itself is just want to know that whether your p-value, how do you calculate the p-value, how do you know that whether you reject or do not reject the null hypothesis. Okay, so they just provide you the 4 different examples, the last one also here. Okay, then they explain about the scenario. Okay, so this one will be your the third paper on the here on the extension on the over dispersion test. Okay, so when in terms of the comparison with the above, the first one and second one, as you have observed that their application, they provide the information is not as much as here. Okay, when they carry out the test, they provide the graphical way. Okay, so this one they do not provide the much of the test itself. Okay, so all these things about the test to justify your data, how good your data, how good is your fit, all these things is actually is quite dependent on the what are you going to show in your research. Okay. Okay. So this one will be the 4th example where they have a carry out the test and then they show you the p-value. Okay, what is the p-value for the test here, and then they compare with the existing test. Okay, so these are the 4 here. Okay, so after that they provide the conclusion, will say that what are the advantage of their techniques extension of the over dispersed test. Okay, so any student who are interested, you also can be working on this particular area of the come out with the new test. Okay, not only for the count data, you can be extend the existing technique to the new test, other apply in the other area. Okay. So the third paper will be the on the also you need to support with a lot of the theory. Okay, because if you observe it, even though they propose the test will be very short in the journal paper, okay, the way of the presentation here is very short here, but in fact they have derived out the formula where the journal itself is not enough space for them to provide the full information or the full derivation of the formulas here. Okay, so they provide is as minimum as possible. So this one will be the third paper, is also related to the statistic, but in terms of application, they just show you a few of the different examples. Okay. So last week I have gone through with you also is a quality control papers. So quality control also is one of the extension from the statistic from the statistic knowledge, where you need to construct the control chart. So the idea of the control chart is derived based on the like the confidence interval idea. Then of course you want to derive out your confidence interval or the control limits of your control charts. Then you need to know what is the distribution of the data. Okay, if they under the certain distribution, whether your data will behave or the control chart will behave well or not. So when you are working on the control charts, this is one of the paper on the control charts. Actually, I show you is two control charts here. Okay, the first one is the control chart. In fact, I show you is a 3 control charts in this example here. So when if you are working on the control charts, then you know that the criteria to do the evaluation under the application will be the average run length of the control charts itself. Okay. So in the 4th paper here, this paper they will have a control chart for the Poisson distribution. using a modified EWMA statistic. Okay, so if you read the title here, you also know that they are modified the EWMA statistic. Means that EWMA statistic is one of the techniques under the exponential weighted moving average. Okay, in the quality control chart, you have one control chart is called exponential weighted moving average. But in this paper here, they want to check out the control chart if they follow the Poisson distribution, and then they using the technique is called the modified. They modified the EWMA chart. Okay, so whether they modify or what, I mean they can be proceed with any of the new control chart. But if they want to evaluate how good the performance of the chart, then they need to use the average. Okay, they use the run length. Okay, run length distribution. For those of you who are working on the quality control, then you know that most of the time the author will be compare how good the performance of chart, then they're using the run length here. Okay, so they will provide the average run length and standard deviation of run length for the existing chart with a modified EWMA chart. Okay, so of course they need to compare with the existing chart to show that how good is their proposed chart as compared to the existing control charts. Okay, so beside this thing, when you go for the quality control paper, most of the time they will show you the control charts with their control limits to show you how the data is look like. Then how you're going to view or the performance of the control charts. Okay, so different when you're working on the different area, you have a different application examples. At the same time, you also can have a different technique to present your application and then justify your technique through the application. Okay. So in the fourth example here, this one is one of the paper is published in the year 2017. Okay, it's a control charts. So these are the highlight of the point of the control charts. So in the control chart, I do not want to go through this thing. Okay, in the control chart, what they have is here. They modify the EWMA chart. If EWMA statistics, sorry, they modify it. If you observe it here, if those of you who are working in the time series here, I mean the quality control, you know that the first part is actually the EWMA, but they modify it means that they plus another component here. There is a justification why they need to plus another component. They cannot simply be add in something, then they'll claim that their chart will better. So they need to support with their methodology why they have this thing. Okay. So this part is what they have proposed in this paper. But in terms of their application wise, okay, you can be check out all these things. I do not want to go through it, but I just want to show you if you are working on the quality control, then you are your ultimate what objective of your study is actually want to set out the control limits, where you have an upper limit, you have a lower limit here. Okay, you have a lower limit here, you have an upper limit here. So these are the two limits if you're going to work on the quality control charts. Okay, so they have many of the quality control charts. You try to improve it. Okay. So in terms of the examples here, of course, they need to compare with the existing techniques. Otherwise, how you want to say that your proposed modified EWMA chart will perform better than the existing set? So you need to provide some evidence to show that the existing chart is not working well. Then your technique, your chart will be perform better. So in this case, they will compare with when the k is equal to 0. If the k equal to 0, they will go back to the EWMA chart. Okay, but the example here, they took the example from the textbook because when you carry out the research, especially you want to carry out those of the theoretical research, you have an idea, but how are you going to get the data? Some data is from the company where it's very hard for you to get the data, or some data you need to buy it. So therefore, some of the researcher, they will take the examples from the in this example here, they took it from the textbook. Okay, because they are not the primary data, they will took it just a secondary or the from the other books examples. Okay, so in the quality control, when you go through the application, they will show you this is the control limit here. Okay, they show you the graphical way of the show you that the control limit given here, and then what are the point of the control chart there for outside the control limit or within the control limit here. So if all the point is fall in between the upper limit and the lower limit, then we can say that the process is in control. Otherwise, the process is out of control. Okay, so these are the things is here. And then beside that here, how good is your model? How good is your model as compared to the existing or the how good is your control charts as compared with the existing chart? They will compare with the run length. Okay, the run length of this chart means that if the process is out of control, your control chart can detect it very fast. Okay, if the process is out of control, you can detect the out of control signal very fast. So this one is called the how good is your performance of the chart through the run length. Okay. So here they show you a few different examples of the run length characteristic from their modified EWMA chart. Okay, but I just want to show you is here comparative here. Okay, so they want to compare the out of performance out of control performance of the modified control charts. Okay, so they just want to show you that they want to compare for the two different lambda of here. Okay, so of course, if you let's say I give you the example of here, the 4.5, the mean here is a 4.5. The mean here maybe they will call it as a mean shift. If the shift with the I'm not sure whether it's a shift or what, but you can see here the ARL is equal to 1 here. The value of 1 here is means that if the process is out of control, you need only one sample. The first sample you take, then you can detect the out of control. Okay, so this one is what they expect, the value of 1 here. Okay, so of course all these they have the meaning under the quality control. Okay, if as I mentioned, if you're working on this area, then you will know what is the ARL. So the quality control chart is not only applied in the industry, but later on I show you the example where the quality control chart also can be monitoring for they combine together with the time series, and then they can be apply the control chart to monitor the skewness or the chart itself using the auto-regressive model. Okay. So the example of here will be the out of control. Of course, if you want to know more detail, then you can read out what is meaning by all these things. Okay. So they will show you the example of here. Okay. So for the first one, they show you that the k equal to 0 is means that the proposed with the simulated k equal to 0. But if you change the k equal to lambda over 2, okay, of course in this paper they have a special meaning of the k equal to lambda over 2. Okay, so they can be detect the point is outside the control limit. So this part is considered as an out of control signal. Okay, where else if you're using the k equal to 0, then you do not have out of control. So this one is a graphical plot to demonstrate that how is the graph of the graphical way to present their works. Okay, the control chart of the graphical here. And then since I have shown it to you, I may not say that this paper is not good, but I just let you know that sometimes when you want to present your result, you need to use out the full scale of them. Means that as you can observe it here, the graph itself, they just plot from the 14.2 or 14.3 until the 18. but you have plenty space in between here. Okay, so we try to extend it. We try to maybe when you want to plotting here, you may be starting from the 14, or you just starting from 13 until the 19 here. So you just extend the graph so that people can see it clearly. Otherwise, you can see that your graph is occupied only from the 14.2 until 18. So you have many empty space here, where the people do not know what happened with here in detail. They want to know what is the changes of the value. Is it how many of them close to the center line? We do not know the values here, or we cannot see it clearly. Therefore, when you do the presentation, I mean the presenting your output also is one of the skill or the techniques you need to learn, where you produce in this one, but I do not read the paper in detail. Maybe they just leave it for the empty here. They have a special meaning. I do not know. Okay, but if I am the author, I will try to think about it when I want to present my work, how I going to present it. Okay, if I think that is no empty space, is no use here, so I will extend the graph here. I just plotting from the 13 to the 19 or 14 to the 19. Okay, then I can see clearly about all this point here. Okay. Okay, so this one is the what I want to comment on the here, give my my personal comment on the following example here. Okay. So in the control chart here, beside here, of course, I highlighted here is to say that how good is their control charts, why they choose the k equal to negative lambda over 2. Okay, but finally, the whole thing under this the fourth paper, it just want to show you that they compare the performance. They use an empirical example and then they compare the performance. At the same time, in the control chart, they show the control chart graphically to have a imagine how is your chart should look like. So as they show it in the lastly here, they show that the point is changes. Okay, it shows that it's out of control. Okay, so this one is the first example of the quality control chart where they have a fixed control limits. You can observe that the control limit at the 18 is always a fix. The lower limit is always a fix. So you can see that the whole throughout all the points here from 1 until the maybe for 50, all the control limit in this chart, they will consistently the fix. Okay, so this one is for the chart in the here the fourth paper here. Okay. So another one will be here. Another one is also about the control charts. That one is paper number 5. In fact, this paper is me and my co-researcher. We have discussed and then we come out the control chart on this one. Okay, when the control chart, you also can have a control chart deal with the statistic. For those of you working on the statistic, you may know what is meaning by the robust measure. So we have considered the also is some proposed the control charting procedure where we want to detect the change point detection of the robust individual control charts. Okay, so we want to have a charting point of them, and then of course we compare the performance of the existing chart with the proposed techniques. Then our proposed technique will work well than the existing technique. Then of course in the following examples here, in terms of the methodology, last week we have mentioned to you we can carry out the simulation to justify our techniques. Similar to this paper number 4 also, they carry out the simulation to justify their techniques. At the same time, they also provide the real example. Okay, because when you provide the simulation study, people may not be know how good is your techniques in the real application. Okay, so in the paper number 5 here, you can see that this one is the change point of the for the control chart. That one will be the paper number 5 here. So this paper is published in the year 2017 in the Industry Engineering Journal. I think it's an engineering journals here. Okay. So this one, the methodology, we don't want to discuss it anymore because this thing is background on the methodology what we have considered. Okay, this one is all is about the Huber techniques. That one is a robust statistic techniques. Okay, so I just want to show you the application side. About the duration one, we don't want to go through it. Okay, I show you the application side on the graph itself. Okay, when we go through the application of this example, we also took it from the certain of the books here or from the journal where we have a data set. Okay, because when we want to get the real data set, it's quite difficult for us to get the real data set. And then if your real data set do not have a change point, do not have this type of the characteristic, your proposed technique also you can't demonstrate that your technique is working. Okay, so I just want to show you is this one is a graph here, as you can observe it, this one. Okay, if you observe that the control the point when they collected for the data is altogether from 1 until the 30 data, you can observe that the process, this one we can treat it as for example the values here. You can see that the value here will increase. After that they have a slightly increase here, and then they have an increase of here. So this part will be have an increment here. Okay, they are from here towards here. And then if you're using the fixed control limit, you can detect this point is out of control. But in fact, if you observe the pattern here, you can observe that if we can group into the 3 parts, the first part here we can consider over here is the bottom here. The second one will be the middle of this part of data where their mean is around here. The third part will be somewhere around here where your mean will be give out. So if you're using the ordinary way of the techniques, you can't detect any of the, in fact, they have already have a point change. Means that they are from the lower mean to the middle mean to the higher mean. Okay, if you're using the ordinary X bar chart. But if you're using the following one techniques here, then you can observe it. You can have this one will be the control limit for the first part, then followed by control limit for the second part, and then followed by the control limit for the third part. So if you can detect the change point here, then this one is really your out of control point. Okay, but if you're using the fixed one, you will detect that this one is out of control, this one is out of control, this one out of control, these 3, 1, 2, 3, 4, and the 5 points are considered out of control, where you never take care about actually the mean have shifted. So this one is one of the examples where you can observe it here. Okay, and then you have another graph of here. If you're using the proposed of the techniques here, if you're using really the proposed of the techniques over here, then you also can detect the change point. But in fact, you only can detect out of control point is here. Where else on this one, they're using the DMRCP procedure. They can be detect also here, but you're not aware that this part also the mean have been changed. They can be changed to another part here. So this one is show you that they have a first part, they have a second part, they have a third part, and the fourth part where the mean already shifted. Okay, so this one is what we use the change point detection for the control limits. Okay, so the change point not only in this quality control here, in the statistical quality control, we can observe that there is a change point. But you also can observe that in the time series data, you also can detect the change point. Later on, I will show you also another technique is where they use the change point to detect how many of the change point they have. Okay. So in this example of here, in this example, the control charts also will always show the graphically of their control charts. How good is the performance? But some of them they may be not show, and then they also will be compare the performance of the different charts. Okay, even though you have proposed it, you need to compare the different performance to have a graphical view. How good is the chart compared with the other charts? How good is your techniques to detect the out of control signal? Okay, so this one is another example. You can be observe it here. Okay, so if you're using another technique, AMR technique, also is you can have a flat control limit, you can totally unable to detect any out of control at this point, and then you only can detect out of control at this point. Okay, then they detect the wrong control limits. Okay, so this one is one of the examples of the how do you apply the change point, and then you get the values. You can present your values in terms of the graphical ways of you show all the control charts, or you can be carry out the compare the performance of here. So here is the values for them to compare the performance. Okay, so this one will be your the fifth papers on the here. So these two papers will be together where they show you the control charts. Okay. So the following one, before I go to the paper number 6, maybe I go through the paper number 7 also. This one also is a control chart. But if you read out the control chart here, the author have proposed what they call as a MAD control chart for autoregressive model with the skewed normal distribution. You can see that they have a lot of the statistic element inside there. They have one is called the MAD control chart. For some students, maybe you know what is the MAD, median absolute deviation. This one is one of the robust measure for the robust measure. So they formulate the control chart based on the MAD. At the same time, they also consider their data consists of the autoregressive model. Then also another thing is where the distribution of the data is a skewed normal distribution. So you can see that they have a many component of the statistic knowledge inside the one paper alone. Okay. For example, just now in the first one, you want to know the distribution. Of course, you need to derive all the property of distribution. But when you go through the distribution, you need to know the estimation techniques. Okay. The similar for the second paper. For the third paper, you need to able to derive out the test alone, and then at the same time, you need to know the distribution of the test statistic, and then you come out with the extension of your test. Okay, so for the fourth one just now, also is a control chart, but they modified the EWMA, and then they apply to the composition distribution. The composition distribution is also one of the discrete distribution. So they will come in with the distribution. So if you have a one distribution, you can incorporate into the control charts idea. Okay. So for the fifth paper here, the author have discussed on the robust techniques. At the same time, they also use the change point detection. Okay, for the control chart. Okay. Then for this one, the paper number 7 just now, I also will show it to you that they are using a lot of the different knowledge, the robust measure, there is a autoregressive, the time series, autoregressive idea, and then there is a skewed normal distribution. Okay, so when they deal with the control chart, of course, they will compare their control charts with the existing charts. How good is the performance of their proposed chart as compared with the existing charts? This one is normally, this one is a usual way of the presentation, and then they provide the empirical example. After that, they also show that the graphical presentation. So these three papers will consistently show you the different control charts. Okay, to illustrate out what is the performance of your control charts. So that one will be the paper number 7. Okay, so these control charts, I do not want to go through all these things, but this control chart, they will concern on the auto-correlated data. Because you deal with the autoregressive model, so therefore your data have a auto-correlated. So their proposal of the chart will want to observe how good is their chart to detect the out of control if they have autoregressive with the skewed normal distribution. Okay, so they also provide the justification why they need to do that. Okay, so you can be read from the major problem in analyzing the control chart is with the auto-correlated data. This problem can be solved by fitting a suitable model to the data and use a control chart for the residue. Okay, so the problem becomes very important. when the distribution of the observation is non-normal in addition to being autocorrelated. So they have mentioned here, much recent research has focused on the development of appropriate statistical process control techniques for autocorrelated data or non-normal distribution. So there are limited studies will concentrate on monitoring the process mean on the both non-normal and the autocorrelated data. So therefore, this one is the objective for the study. They want to study both of them at the non-normal, at the same time will be the autocorrelated data. Then they're using the MAD control charts. But in fact, if you know the idea, we can be consider other control charts and then with the other distribution, because the skew normal, the skew normal will be quite general enough. If you want to have a new control chart, maybe you do not want to propose a skew normal data, you can be or skew normal distribution, you can be consider other quite flexible distribution. Okay. So this one also the quality control, where they have gathered a lot of the information on the time series, is the auto-regressive order one. Okay, so they come with the time series idea. Okay, I don't want to go through the chart itself. So of course, this paper have carried out the simulation study. Okay, we go through the application sites. Okay, so in their application sites, they do not provide, in this example, they do not provide you the real application site, because as I mentioned before, sometimes you want to get the real data, it's not easy for you to get the real data. But in this example here, they will provide the simulated data. So they simulate from they have this type of the scenario of the auto-regressive, and then they consist of the skewed normal distribution data, and then they check their performance of the chart performance. Okay, they're using the following one to check their performance. Okay, so the first one will be the here, there will be the SKE view, the skew. Then the second one will be the MAD, and then the third one will be the WSD. So they compare the performance of all the charts using the graphical way to present it. Besides that, they also produce you the values of here. Okay, so if you observe it, this thing, of course, we want the value. Delta is normally the notation for the shift. If they don't have the shift, they will fall on the 370. This one is if you are working on time series, you are working on quality control, then you know what is meaning by 370 here. If the process is skewed or the process is shifted, then they are able to detect the out of control very fast. Okay, so this one is how they want to measure their performance of these three charts. Okay, under the phi is equal to 0.25 and so on. Okay. So in this paper, they will gather quite number of the information. One is a robust statistic. Another one is you need to know what is meaning by the time series auto-regressive of the order one. And then the third one, you need to know about the distribution. Okay, so there is a justification or there is a reason why they want to use a skewed normal distribution. Okay, so all these things is very important in the research, where in the statistic you can be try to using the different distribution, the different models to formulate your the problem. Okay. So for the paper number 7 here is also about the control limit, the control charts. Okay. So these are the 5, and then this one, the number 7 is on the statistic side. Okay, but of course in the statistic side, you not only use a statistic knowledge. The statistic knowledge can be applied in the other discipline. Okay, but they may be not published in the journals you have. Okay, so we have a following one is this one is on the can we say that is a finance or finance is a finance, but the idea of this paper the title itself is a look like it's a finance, but the inside the research work is basically on the statistic. Okay, the idea is on the statistic. So in this paper, is actually the estimation and the forecasting with the logarithmic autoregressive conditional duration model. So comparative study with an application. So the application will be provided, and then we compare, we derive the estimation techniques using the two different estimation methods, and then also compare with the two different models. Okay. So the empirical example will based on the duration data is provided. Then of course, in this example, when you go through the starting from here example, when you want to modeling this one is some sort of like the time series data. Okay, in the time series data, then of course you need to compare their performance of the in-sample estimation and the out-of-sample forecast. Okay, so these are the most of the time when you compare the time series, you need to carry out this thing. Okay, may not be compulsory, but most of the time you read at the time series paper. If they want to provide the empirical example, also depends on their objective of the study. Then you can observe that they want to show you that how good is the in samples estimation results, and then how good is the out of sample forecast results. And then they use the different criteria to measure how good is your models in the in-sample estimation performance and the out-sample forecast performance. Okay, so basically they were using the loss function to measure how good is the measure. Okay, even though the loss function also we have a many different type of the loss function in the previous last week I also show you that they can be have a different type of the loss function. Okay, so beside the loss function itself is also may not be enough. So you can be carry out the test, the hypothesis test. So in this one, actually they carry out the DM and the SPA test to test that how good is your model as compared with the existing models. Then we can be justified that. So you need to incorporate different type of the measurement to judge that how good is your suggested methodology, either the methodology or models. Okay. So this one is here, number 6 here. In fact, this is my paper is published in the quite some time in the year 2014. Okay, so this paper will be published in the the expert system with the application. So we want to study the theory part will be here. Okay, the theory part is actually we are comparing the two different estimation techniques. One of them is called the estimating function techniques, where you need to know a lot of the statistical knowledge, how to derive out the estimating function, the theory of estimating function. So you need to derive out all the equation out to show that to formulate, not to show, to formulate all the estimating equation. Because when we're talking about the estimation, we want to estimate the parameter of the model. So how are we going to estimate? For example, if you are using the maximum likelihood, then you need to write down your log likelihood function. After that, you find out the optimal solution for your log likelihood function. Then you obtain your parameter estimate. But if you're using other estimation techniques, then of course you need to derive out the estimation using the techniques given. Okay, so therefore in this one, in the here is just the methodology parts where you need to derive out all the theorems. Using the theorems, you derive out all the equation for you to use to estimate your parameter. So these are the works. This one is a theory part. I don't want to go through it. I just want to show you the empirical example. But of course, in this study, I also provide the simulation study to justify that how good is my estimation or the estimates as compared to the maximum likelihood estimates. Okay, so the simulation also is a previous work. Okay, so now in the application side, in terms of the application side, okay, so we are doing the fitting of the data. We're doing the, let me go through it. The application is here. The data is here. Okay. Let me, yeah, the first page of here. Yeah, here. Okay. So we compare the performance of the model itself. We use the real data from the IBM data. We use the IBM data. Then after that, we compare the IBM data with the fitting to the different models. And then at the same time, we also using the different estimation. We want to check how good is the model. So as I mentioned, we need to compare with the in-sample performance and the out-of-sample forecast. Okay. At the same time, we carry out the hypothesis test also to test that how good is our model as compared with the others existing models. So in this one, in this example here, we have carried out a few of the more than the just now previously the test. Okay, but as I mentioned, this one is may not be the compulsory because we put in the different tests, different loss function is just want to justify that our applicability of the techniques. So here, this one is a time series data. I use the time series data because during that time, I do not have a data. So therefore, I get the data from the textbook. So this is the data, the real data for the IBM data from the textbook. And then we use it, model it to demonstrate our techniques itself. Okay. So here is the results. We want to compare how good is no, this one is a estimate, the simulation. No, I show you the result here. Yeah, here. Okay, we are doing the fitting of the different models with different estimation, the estimation methods, and then from here, we want to know that the in-sample performance and the out-sample performance. Okay, so here are the parameter estimates. Then we compare their performance of the model itself. Okay, because in this study, we just want to show that how good is our estimation. So therefore, we just compare the in-sample and out-sample performance here. Okay. And then besides that one, you also need to we actually is we carry out the hypothesis test to further support our answer. So we carry out what they call as a DM test, the Marino test, and then we also carry out the SPA test to justify that our performance of our models. Okay, so this type of the work you can observe it. They have gathered the different area, research area. One is your statistic knowledge, you must be there. And then at the same time, you also need to know like this thing is a duration model. What is about the duration models? Okay, then how are you going to judge your model? Okay, so this one is basically your paper number 6 is related, very much will be on the statistics side. Okay, but their application side will be in the financial model. Okay. So this one will be the paper number 6, okay, and the paper number 7. So we go through the another one here, okay. Okay, maybe we stop for the while. Now it's already 7:30. Then we stop for the while. We continue with the data on the following example, where I can show you to you that you can use a different technique to present your results. Even though you can see that you have a graphical presentation, but you can use a different type of the graphical presentation to present your results. Even though if you are working on the time series, you also can be checked out. Okay. So I think I stop for the while first, then I continue later. We start at the 8 o'clock.